Hey there, welcome to another video. This one will be the learning module about simulation methods. That's the one on the sequence of lessons that you have for the CFA exam level 1 for this year. Okay, not a long module. It was a module that it's the first time that became an independent learning module. It was in 2024. Until then was simulation methods, right? And sampling methods was just embedded into the curriculum in other topics. Now, simulation methods, estimation and sampling, which is the next video, are separate. So that means the CFA Institute believes that we're going to need to give more attention to those points. That's my take from this. All right? So not a long, it's not going to be a long video, because very few learning outcomes. I believe there are 3 learning outcomes, very few key points, okay, which we're going to be seeing in other topics in the future. For example, simulation is going to be present in portfolio management and fixed income. Okay, a lot of fixed income questions, a lot of fixed income topics, require simulation. Right? You're going to simulate to come up with some interest rates that you're going to use to calculate the price of a bond or fixed income instrument. On portfolio management, you're going to do stress testing and simulation. The stress testing and simulation, very, very important. And use the concept that you're going to learn here. So I believe here this simulation that's starting your curriculum now in QM, right? The first topic, that's going to be important for future topics. That's what I mentioned about others as well, like probability trees. It's not going to be super important for QM per se, but probability trees are going to be important in fixed income, in options, right? Same for simulations, right? Or simulation. All right, let's go to the learning outcomes and start going one by one here. All right, friends, so there you go, learning outcomes. You have 3 learning outcomes. Explain, describe, and describe. Take a look. That's all you have there. Explain, describe, and describe. Explain the relationship between normal and log normal distribution, and why the log normal distribution is used for certain analysis that you're doing in finance. Okay, so the question is when to use the log normal distribution, when to use the normal distribution. Okay, so if I'm talking about returns can be positive and negative, right? So if the returns can be positive and negative, I have to rely on a probability distribution that accepts positive and negative numbers. Normal distribution does that. But if I'm talking about just measuring the asset price, I'm just seeing the variation. I want to know something about the price of the assets. Price cannot be negative, right? You don't have a negative value for a stock. The minimum it goes is 0. So that's what we say, the asset prices are bounded by 0. It cannot go below 0. Well, in that case, I cannot use the normal distribution. The normal distribution is not going to be helpful for me. I'm going to need to use a different distribution that does not accept negative numbers. Example will be the log normal distribution, right? The log normal distribution will give you only positive outcomes, not as the outcomes, and therefore is the one we're going to be using for that scenario. Okay, so there you go. Second one is Monte Carlo simulation, and describe and explain Monte Carlo simulation. Okay, now Monte Carlo simulation have some assumptions. There's some pros and some cons. So one thing that's going to be helpful for you here, because Monte Carlo simulation is important, right, is that you remember, okay, what are the pros and the cons involved on Monte Carlo simulation. Okay, some assumptions that you have, right? I'm going to explain here to you some of them. I'm going to show to you how Monte Carlo simulation is performed, but I think it would be very good if you kind of create a little table for yourself and you put it there. Okay, what's one, what's the other, now what's the pros, what's the cons, what's the assumptions behind. Try to understand Monte Carlo simulation and why so used in finance. All right, and the last one is sampling and resampling. We're going to talk about bootstrapping resampling. I want you to be careful here with sampling and resampling. Sampling is getting a population, and from the population I'll take a sample. That's sampling. Okay, there's methods for that. We're going to learn on the next video, the next module. Now, if you have a sample, and you want to resample, then you're going to use another method. That's what bootstrapping it's all about. Bootstrapping, jackknife, it's another one. But this one here, it's focused, right? The learning outcome is focused on bootstrapping. Okay, so let's talk about bootstrapping here. All right, that's it. Those are the three learning outcomes we have. Look at, we have like 5 key points here. The log normal distribution, okay, the continuous compound rate of return. That's not gonna be a log normal. Returns, it's could be positive or negative, so returns are gonna be like more a normal distribution or a T distribution. Monte Carlo simulation, definitely, and the bootstrapping. That's it. We're just gonna cover all of those topics, right? And then you're gonna practice. Now, these simulation methods, I believe there are more chances to be conceptual questions than analytical questions. So understand what's bootstrapping, know how to explain how to bootstrap it, understand Monte Carlo simulation, know how to explain Monte Carlo simulation, pros, cons, when to use, right? And things like that. All right, that's it. Let's go now for my points related to the simulation method. There you go. The key points we already addressed. So again, go straight to the explanation now. All right, first one here. Continuously compounding formula. We already seen that on the module 1, rate in returns. We saw also in time value of money. But again, right, let's see one more time. Is the value or the price multiplied by the constant E, 2.7182, at the power or R, the rate of return, times the T. Okay, so make sure you know how to calculate that. Right beside, you have I put an image of the log normal distribution and the normal distribution. Look at that, log normal, normal. Okay, so the log normal distribution has this shape here. If you have to say which type of problem the log normal distribution has compared with the normal, it's what? Kurtosis or skewness? Skewness, right? Take a look. This is skewed. Which type of skewness do you see on the log normal distribution? Which type of skewness do you see here? Right? You see a positive skew or a negative skew. And you see positive. Look at that. It's going to the positive numbers, right? Positive skewed. So the log normal distribution is a positive skewed distribution. That could be a question. I don't know. The normal distribution has the bell shape. The normal distribution accepts positive and negative numbers, although this image here doesn't show that, right? But this goes to the infinity, right? And here is bounded by 0. That's it. Now, returns, we can say a couple of things that you could see here. For example, if the returns of a stock is normally distributed, we can infer that the price of the stock is log normal distributed. Okay, so those are the little things that could become questions on your exam. Like one little line on the official material saying about, right, that if, like there, if the returns are normally distributed, consequently the price of the asset is going to be log normal distributed. That's one line on there on the official material that could be used to become a question on your exam. Okay, so again, I know it's difficult to cover every topic, every point of the official material. That's what I'm doing the videos and the groups, and my help to give you some kind of tutoring or etc. Whatever I can do. But in the end, is how well you grasp that official material that's going to make the total difference. Again, questions that you see on the ecosystem will not appear identically on your exam. But if you see a question on ecosystem about the characteristics of the log normal distribution, characteristic of the normal distribution, then attempt to, okay, hold on. This question could appear in my exam differently, obviously, than this one, but on the same idea. For example, they remove the 3 alternatives that you have on the question ecosystem, and they put 3 new alternatives for the exam question, and they change a little bit the writing. Very, much possible. That's how you want to study the ecosystem questions, is having in mind, okay, how this question could appear differently for me. Okay, good. Let's talk about then the Monte Carlo simulation, right? Let's talk about here, right? So Monte Carlo simulation, okay, it falls, right? That's the name comes from the casino Monte Carlo, right? Famous casino, and then that's what the name comes from. But the idea is this. Look, let's simulate something. So how do I simulate something? Well, let's imagine what's going to happen during the day. Right? Simulation, for example, is very well used, for example, in an airport. We're going to simulate a chaotic day in an airport to see, what happened. We're going to simulate a very chaotic market day to see what happened to my portfolio. I'm going to simulate several paths of the interest rate so I can find the interest rates for next year and the following years. So Monte Carlo simulation is so well used, okay, in finance. So look at the idea. Imagine here a very simple example that I'm using. Okay, I took the demand per week right here. Okay, there you go. The demand per week of anything, 0, 1, 2, 3, and 4, and how many times, right? So the frequency that I had, like during a week, there should be like this frequency of the demand for zero for that product, for 1 unit, for 2 units, for 3 units, for 5 units, and then you have a frequency divided by according to the how many units someone is going to consume. Transform that in percentage, and now you have that the probability of selling 0 units is 20%, the probability of selling 1 unit is 40%, probability of selling 4 units is 10%. Now create, that's what the name Monte Carlo simulation comes from, the roulette. Create a circle that looks like a roulette, right? And then divide it in sectors according to the probability of each one happen. So look at that. There's a 40% probability of selling 1 unit during that period. We're going to take that circle and you're going to divide 40% of that circle. 40% of 360 degrees, it's the degree of this angle here, and then you create this sector, and you do the same for the other sectors. Great. So you see the sale of 1 unit in my example has a bigger sector in the circle because it has a bigger chances to appear. And then this is going to be spinning, and spins millions of times, let's say, like a large number. And that's going to simulate an event. How many times I should expect this or should expect that to happen? And if this happens, right, what could we do? That's the rationale behind Monte Carlo simulation. Okay, the rationale behind. What you should do is learning the pros and the cons. Okay, so for example, the pros and the cons. The pros and the cons is, for example, it relies on historical data. Historical data sometimes might not, the future might not repeat the past. So that could be an example of a limitation, right? If you only use historical data, right? It sometimes doesn't have the subjectivity that's necessary for something, right, to happen, right? You need some kind of subjective analysis to incorporate it there. Sometimes the Monte Carlo simulation does not allow that. On the other hand, it creates several different possibilities, so you can see a bigger picture, and he also does not rely in normality of the population, right? Normal distribution, probability distributions, right? The Monte Carlo simulation can be used for any type of population. So what I advise you to do is to create a table, and I said, you could have provided that for us. Yes, I could, and I can, if you ask me. But I thought, look, why wouldn't it be much more pedagogical for you, right, for the learning purpose? So if you do that yourself, right, create a table so you write it, so you can, don't copy and paste, just type to write, okay, Monte Carlo simulation, pros, and you type each one, negatives, you type each one, then you take a picture of that, then you put in an error, and then you can study that. I think that's more effective and more efficient. All right, friends, let's finish. That's the last topic on this module here, which is explaining to you resampling. In this case, by bootstrapping. That's the one that they use it on the material. So I have here for you an example, steps of bootstrapping process. And if you understand the process, you probably will be able to answer a lot of questions related to this process of bootstrap. Okay, so that's the best way to learn bootstrap. It's just go step by step. In this case, if you wanna, there's several videos on YouTube, very simple videos with little toys, with colorful, with little circles, geometric figures, whatever, to explain bootstrapping. So again, if you don't find my explanation too helpful, if you don't find the explanation of the CFA Institute lessons too helpful, you always can go to online and get some short videos to explain those points. Same for Monte Carlo simulation. Okay, those are classic topics in finance. There's a lot out there regarding explaining each one. Well, let's see this example. So I'm going to do a bootstrapping. So what do? I have a sample. I don't have a population. Let's go. What is the difference between, what is the characteristic of bootstrap, or which of the following is not true about bootstrapping process? Bootstrapping use the population. That's not true. Therefore, that will be the alternative. See? Think about how those questions could show up in the exam. Right, step one. Suppose you have a small sample, you have 10 stocks, right? Now I take the return of each one. A sample of stocks equals to 10, right? So I take the return of those stocks. So 2%, 4, there we go. That's my sample here. 1, 2. Okay, and that's not in order. See, 2%, 4, 5, 3, 6. There you go. That's my sample. Great. It's a small sample, but I need to do the best I can with that, right? So if I want to do some kind of analysis. So let's resample those numbers, okay? So what you're going to do is like you want to create new fake data sets, okay? Also called resamples. Okay, and from this small sample, so I have 10, I want to create fake little samples, 10 little samples from my sample of 10 elements. Okay, so what you're going to be doing here, okay, you can do it, for example, a pick and choose, right? You can do several ways here, but let's say a pick and choose. So I take one of each, so I go there and I pick one. So look at that. You randomly pick returns from the original sample with replacement. I'm going to even kind of highlight this word, with replacement. It's important in the bootstrapping process. On the next process they're going to learn on the next video is called jackknife. Jackknife, you do not put a replacement. So they attempt for the characteristics of each method, because that could be a question, or could be a true and false, or least likely, most likely question. Okay, it could be one of the alternatives. All right. Then you're going to repeat keep repeating this process until you have 10 numbers, right? So that means you could take the number 2 10 times, yes. You could take the number 4 10 times, yes, because it's a replacement, right? Right? So then you do that. So look what you're going to be doing now. You're going to calculate the average. I don't know how to put candles here. Candies? No. The average return. Look at that. Just got a typo here, friends. Okay, calculate the average return in this new sample. Okay, so in our example here, for example, I got 5, then 6, then a 3, then a 2, then 2 again, then 4. Right? What I do the average. Okay, so the average he gave me here 4.1%. That's the average of a sample that I took from a sample. So take a small sample of 10, take it 10 numbers out of that with replacement, do the average, put it on the side. Do it again, and then you're going to have a sample of average, okay? And then you have the step number 5, collect. There you go, because 4, you're going to repeat the steps 2 and 3. In the step 5, you're going to collect all the average returns from those resamples, right? You can calculate the average, right, of all of them, and that's going to be like you call bootstrap estimate, the average, how much you expected, right? So by using bootstrapping, they call it simulation, right? You can make more reliable statistics when you have limited data. That's when you use bootstrapping. Could be a question. Which of the following is true about bootstrapping? By using bootstrapping, you can only make more, you know what I mean? And sometimes it's going to be written exactly as in the official material. That opens the door here for you for me to tell you something that I think is extremely important. only use the official material as reading material, okay? Because the official material contains phrases, keywords, way of asking, way of presenting that could be beneficial for you in the day of the exam. If you're going to buy a book written by a third party based on the official material, you'll be missing something there, in my opinion, right? So stick with the official material for harder than it is, right? That's why I'm offering you this strategy here, now this proposal that I'm creating of making the videos, open the groups, and be by your side during all this process. That's helpful. Now, buying a book that was written based on the official material, I don't find helpful, okay, in this case, but that's just my opinion. All right, I think we're done. Let's go back and check, but I think that's done. We did the log normal distribution and the continuous compounding, okay? Every probability distribution is based on continuous compounding probabilities. But there are other distributions. You have the discrete distributions. Discrete distributions are not continuous distribution. Discrete distribution is a distribution that only accept round numbers. For example, if I want to analyze the numbers of vehicles that breaks down and need mechanical assistance during a particular day, right? I can only have one vehicle, two vehicles, three vehicles, right? I cannot have 1.34 vehicles. You see, it doesn't make sense. So we use continuous probability concept when the expectations of the results are infinite. Returns is an example. 3% is an expectation, but 3.1 is another expectation. 3.1345% is another, and so you have an infinite possibilities. Then we're going to use the continuously compounding, continuously distribution. Everything's continuous when you're talking about return and prices as well, right? The price of stocks can be anything, right? An infinite number. Log normal distribution is the one that's bounded by 0, okay? Is this one here. If you want to remember the shape, log normal distribution is skewed positively. Monte Carlo simulation and bootstrapping were the last two topics, the last 2 points of this module here. Great. That's it, friends. That's, I said, it would be a short video because you have to go straight to the point here. That's the idea, right? We don't want to waste your time. Now it's time for you to practice the problems at the end of the book, if you have, the end of the chapter, or at the ecosystem, the practice session, if you already have access to it. Okay, I am done with this module here. The next one, because I always like to talk about the next one, it's an important one. It's estimation, inference, and estimation. Okay? So we're talking about here, we're going to talk about sampling. Now, more specifically, choosing the right sample. And what kind of inferences can I make towards that sample? Is that sample normal distributed or not? Right? What is the best way to select that sample? Right? We're going to talk about bootstrapping again. Okay, we're going to talk about other methods of sampling. So remind you that bootstrapping is I have a sample and I need to resample that bootstrapping. In sampling itself is I have a population and I need to take a sample from it. Okay, there we go. Okay, friends, I hope this was helpful. Okay, again, you know what to do if you have questions, right? But now I'm ending this video now. Bye-bye.